Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz Helmi bin Muhammad Zainafi A158806. I will do the project of the design of shaft. So the introduction is: first, shaft is a common and important machine element. It is a rotating non-member. In general, has a circular cross section and it is used to transmit power. In this report, the analysis of crankshaft design, concept and mechanism is presented. In evaluating the design, the following criteria were considered, which is the number of cylinders of the engine, the size, the dimension of bore and stroke, the maximum power output that can be produced, and the strength of material chosen. The conceptual design for crankshaft parts is presented using 3D isometric drawings. For the objectives, I have two, which is the first one is to design a crankshaft for a 4-cylinder internal combustion engine that produces maximum power of 100 horsepower at 4000 rpm. The second one is to carry out stress analysis on the design crankshaft. Next is the methodology. There are a few types of methodology, but the first one is types of crankshaft. The crankshaft in the engine has the task of converting the up and down movement of the pistons into a rotary motion with the aid of the connection doors. There are two types, which is by the position of the crank and which are center crank and overhang crank. So I decided to choose the center crank because the engine is a 4-cylinder engine. A multi-throw crankshaft is needed instead of a single throw crankshaft. Next is design procedure. So the parameters of the selected engine are determined, which is the number of cylinder, which is 4, the number of strokes 4, rated power, engine speed, bore size, stroke length and crank radius. After that, factor of safety. Factor of safety, I make it constant variable, which is 3 based on the yield strength is used. Next is crankshaft material. The material selected for the crankshaft is cast steel. This is because crankshafts are constantly under fatigue, loads and high stress. Thus, a tough and fatigue resistant material is needed for this crankshaft. Therefore, cast steel is selected due to its high strength and toughness. Next is design and calculation. So based on safety factor, which is 3, the stress allowable is 83.33 megapascal. Stress allowable is 41.67 megapascal. Next is maximum bending moment, which is horizontal reaction force at point 1, which is 6.3935 kilonewton, and horizontal reaction force at point 2, which is 38.361 kilonewton. For the maximum torsion, I also considered, so it will become the final is 27.765 kilonewton and HR2 is 28.26 kilonewton. So next is design crank pin. Design crank pin, we use the parameter that is required from my methodology, and lastly become 29.43 mm for the cramping length, but I used to use the round off of the 29, which is 30 mm is chosen. For design of crank, the dimension are acceptable because my maximum stress is 51.3 megapascal, which is less than stress allowable. So design of shaft, we use shaft length, which is 44 mm. And lastly, result. I use result which is finite element analysis, and the crankshaft loads have figure shown in my PDF. So the loads of FP, which is 3.33 kilonewton, is added to crankshaft, and then the first principal stress is recorded, the third principal stress is recorded also, and lastly von Mises stress is about 135.1 megapascal, and the displacement is shown, and the safety factor also shown in my result. So the conclusion is the crankshaft has dimension of crank pin diameter, which is 79mm, length of crank pin, which is 30mm, web length, which is 300mm, web width, which is 102mm, web thickness, which is 58mm, and shaft diameter and shaft length also recorded. So that's all for me. Thank you.